So we were discussing the DBS, direct broadcast satellite systems, right? And then we even saw uh, as to what is going to be in the indoor unit, right? And what is going to be in the outdoor unit. And what are the things that are needed in order to incorporate a proper uh, communication system was also looked into, right? And we even saw the outdoor unit, right, which had receiving antenna, and then the range of the diameters of these antennas, okay, and then the downlink frequency band, which ranges from 12.2 to about 12.7, okay. So this comes under the KU band, right, and this is having the range of about 500 megahertz, okay. So which means if we try to calculate, okay, so we should be getting about 32 channels, okay, which is about 24 megahertz wide, okay, for 500 megahertz. So if you can divide, do a small math, okay, so you should get these numbers, right. Continuing about the outdoor unit, we even discussed about the down converted signal, which is going to be about 950 to 1450 megahertz, okay, and the low noise amplification must be provided for the cable input in order to maintain a satisfactory signal to noise ratio, okay. So appropriate uh, uh, amplifiers should be employed, okay, so that there is no extra noise that gets amplified, okay. Then having to mount the LNB outside, so it's not only about getting technically things done right, okay, but also safeguarding your device, okay. So because it's outside, okay, theft can also happen, right. So now we have to continue our discussion, okay, with the indoor unit, okay, where the signal feed to the indoor unit is normally wideband signal, which is ranging from 950 to about 1450 megahertz, okay. So initially it is actually a high frequency, okay, which is about 12 gigahertz, okay. If you can see here, you can see in the diagram, right. So it's about 12.2 to about 12.7 gigahertz, okay. So that's the range. And so if you see here, we have low noise amplifier which downgrades the signal, okay, which means it downscales the signal, and it comes in the range of megahertz, 950 to 1450 megahertz. Okay. So this is amplified and passed through tracking filter which selects the desired channel. So the signal that we have here, which is about 950 to 1450 megahertz, okay, will be actually passed to another filter, okay, and that is called tracking filter. And this will help us in selecting the desired channel. The selected channel is again down converted from 950 to 1450 megahertz range to a fixed intermediate frequency, which is about 70 megahertz. So this is nothing but your IF, okay. So you can see here, you have something called IF, right. So here, from here, it passes on to an amplifier, and then it can track and down convert, because this is in the range of 950 megahertz, so that has to go down to 70 megahertz. So it needs a converter. So it will take the 70 megahertz as this intermediate frequency, and from there is your demodulation, then remodulation, and the selecting. Okay, the selecting of channel happens uh, with the help of oscillator. So we have seen these concepts, right? The 70 megahertz, okay, is your intermediate frequency. So 70 megahertz amplifier amplifies the signal up to the levels required for demodulation. So here FM demodulation is what we are talking about. A major difference between DBS TV and conventional TV is that with DBS, frequency modulation is used, whereas conventional TV, amplitude modulation in the form of VSSB is used. So do you think digital form of communication is better or analog form of communication is better? Which is good? Okay, so the digital format of communication is actually better, okay, because the losses can be nullified, and with analog, it becomes difficult for us to get a proper clarity, proper picture quality, proper video quality, and that's the reason for us to migrate from analog to the digital mode, right? The 70 megahertz intermediate frequency carrier therefore must be demodulated, and the baseband information used to generate a VSSB signal is fed into one of the very high frequency or ultra high frequency channels of a standard TV set. Okay. So this is the range that we use. VHF and UHF were used previously. A DBS receiver provides a number of functions which is actually not shown. So here, if you can see the receiver section, there are still a lot of properties, okay, lot of functionalities that this receiver does, but we are not showing it here, okay, just to keep the block diagram simple and to show what is really necessary for the purpose of communication. Okay. The demodulated video and audio signals are usually made available at the output jacks. Okay. So all this video and audio signals, so we make it available at the jacks, which is the port, and from the port, it's taken to the next step forward. Terminals also may be provided for insertion of IF filters. So since we have this intermediate frequency, okay, in order to get a fine-tuned frequency, we can even insert filters. Okay, so this is the same use like your guard band, okay, where we try to employ, or we try to nullify your ISI, which is your intersymbol interference kind of signals. And a descrambler also may be necessary for the reception of some programs. So scrambler is when it's used, okay, on one side, then we'll have to use the descrambler also at the other side, just to make sure that these frequencies are separated and they are picked up properly. So by this, what is going to happen? We are going to receive properly, and if the signals are received properly, then these programs can be tuned in with ease. Right. Next, we can see that we have received only home TV systems. So here, the satellite television is a service that delivers television programming to viewers by relaying it from communications satellite orbiting the Earth directly over the viewer's location. So these satellites are not only used for, you know, uh, for security reasons, but it's also used for communication and entertainment as well. The reason why we employ satellite is because it can cover a wider area, okay, capable of covering more than a country, okay. Uh, and if it's intended for a specific country, it can even cover the neighboring countries as well. And these satellites are placed on top of the viewer's location, which means it's just there in the sky, and the signals are received via outdoor antenna. So the antenna that you see on top, okay, is actually directly communicating with the satellite, and due to this direct communication, the signal quality is increased because it takes the signals directly from the satellite, and because of which there is less delay, and the quality is maintained. If you can compare with the communications that happened previously, right? We were not that efficient, in getting those signal free or signal distortion free type of signals, right? Which means a proper signal we were not able to employ. But here with this, okay, because of the modernization and use of technology, we are able to use satellite directly for our communication purpose. Right? The signals are received via an outdoor parabolic antenna. It is also referred to as satellite dish and a low noise block down converter. So this one is needed for us to convert to an IF, okay, intermediate frequency. A satellite receiver then decodes the desired television program for viewing on a television set. Okay, so whatever program that you have decoded, okay, so that can be actually streamed down to your television. Receivers can be external set-top boxes or built-in television tuners. So initially we used to have televisions, okay, having tuner cards, and also separately we used to combine it, with the television called tuner kit. So because of which this used to enhance the signal, and the clarity used to be much better. So these days, all these are not required because it can directly connect to satellite, and the communications are going to be much better. Modern systems signals are relayed from communication satellite on the Ku band frequencies. Okay, as I told you. So these are on the higher end of the spectrum, which is 12 to 18 gigahertz, and these require only a small dish, less than a meter in diameter. Okay, so if you just have a small dish, and that can actually suffice the purpose. The first satellite TV systems were an absolute type now, known as television receive only. These systems received weaker analog signals transmitted in C-band, which is about 4 to 8 gigahertz. Okay, so if you compare those signals, then those were actually not those strong signals, those which were used previously. Okay, now there's a catch here. Okay, as your signal frequency reduces, the diameter increases. Okay, if the signal frequency is higher, okay, then the diameter of your antenna is not required to be much higher. Okay, so due to this kind of low frequency, okay, what was happening is we had to use large 2 to 3 meter dishes, okay, compared to less than 1 meter in diameter. Okay, that's because of the higher frequency spectrum that is employed. Okay. So frequency and the diameter of the antenna changes. So just have a look at this diagram, okay, and this is talking to us about the master antenna television system. So here you can see your master antenna television system, where it has your LHC polarization, which is nothing but your circular type of polarization. Okay. And this is our outdoor unit, okay, the dish, and the low noise amplifier. Okay, so we have two low noise amplifiers, and then the polarization we have here. Okay, um, then we have a diplexer here, okay, wherein it can actually uh, take multiple signals, and then it can um, divert them as inputs and outputs. And the indoor unit, okay, the indoor unit has a power divider, uh, a group which selects, okay, the channel, okay, channel group selector, and then it goes to receiver, various receivers, and then modulators, and then accordingly it is going to get into your television. Okay, so this is your master antenna television system, where it's actually, you know, giving its data or distributing its data to various receivers. Okay, so the systems here are to be more powerful. Okay, these antenna systems are to be more powerful, and these can actually accept the signals, and it can pass through, and once it passes through, we can connect various receivers here, and different techniques are employed here. Okay, modulator 1, 2, 3, and then your indoor unit that we saw previously, okay, which is your intermediate frequency down converter. All these are employed, okay, in this section here. In short, this is also called MATV, okay, master antenna television system. Okay, so the master antenna television system is used to provide reception of direct broadcast satellite. Okay, so this is also used for receiving the signals. Okay, and for example, to tenants in an apartment building. So in an apartment, there will be a lot of units, right? And we can just have one receiving system, and these can be distributed to various units, to various houses, right? So that is going to be your receiver 1, 2, 3. So we can, instead of having multiple antennas, okay, on the rooftop, we can just have one master antenna, and that can be distributed to various units in an apartment. It consists of single outdoor unit, okay, just one outdoor unit, um, and which is the antenna and your low noise amplifier. So this feeds a number of indoor units. So indoor units are going to be the units, example, your set-top boxes, which are inside different houses in the same building. It is basically similar to the home system earlier described, but with each user having access to all the channels independently of other users. Okay, so here what is going to happen, you will have access, you will have your own receiver, and all the channels are subscribed, or it is taken for, and everybody will have access to all the channels. But here previously, as we saw, okay, just a set of frequency is taken, and accordingly the tuning is done. The advantage is that only one outdoor unit is required. Okay, so you don't have to have multiple units on the rooftop. Compared with the single user system, a larger antenna is also required, okay, which is about 2 to 3 meter in diameter, in order to maintain a good signal to noise ratio at all indoor units. So here a larger antenna is required, okay, which is about 2 to 3 meters in diameter, in order to get the reception of signal in a proper way. Okay, so this is about your master antenna television system. So just one outdoor unit, the same conversion process. Okay, and then this power divider is important. Then channel group selector is also important. From here, it starts moving into different receivers based on how many slaves or how many client systems are connected. Okay. So ultimately, sometimes there is one disadvantage with this is that if there's a disturbance in the antenna, okay, then all of the receivers will receive the same disturbance. The noise is transmitted to all the receivers. But the advantage is that you can have just one outdoor unit, uh, okay, on your rooftop. Okay, so there is advantage and there is disadvantage. Depends on what kind of things that we are actually looking for and what we are exactly interested in. Okay, so sometimes that space becomes very important. Sometimes the quality of signal becomes important. Sometimes everyone will not like to have access to all the channels, right? So it actually depends. It's an individual question to be answered. Okay, if we have to go with this DBS kind of system or MATV system. So the next one is CATV, okay, which is Community Antenna TV System. Okay, so please have a look at this um, diagram. So here you can see that from the outdoor unit, okay, uh, you can have a wideband receiver and demodulators. So here, based on the odd even concept, okay, we distribute the channels 1, 3, 5, 7, 2, 4, 6, 8. So based on this, we try to separate the channels, and once it is separated, then we use a combiner, and then finally it goes to a cable distribution. The reason why we are having this kind of system is for a community. Now, the previous one that we saw, Master MATV, Master Antenna Television System, is only employed for an apartment, okay, just for one single building. But here in the community, we can probably look at a locality, an area, okay, wherein this system can be employed. So based on our requirement, okay, we can look into getting different systems and accordingly employ them. Okay, so now we will look into it and we will see what are the functions that is inside your CATV. Now, this is going to be the type of antenna, okay, that we will be using. Okay, so I'll be talking about it. So you can think of the diagram, okay, which we saw in our previous module, okay, wherein for our antenna communication systems, okay, we had used the multiplexers and demultiplexers, right? So those multiplexers are used, mux and demux is used here, and accordingly the channel is selected as to which channel has to come, and these separators are used, and once we have these separators, then at the end we need to combine them. So we combine and then it goes to your cable distribution. Now the reason why we have your wideband receiver is because it can accept wide range of frequencies, okay, because we do not want to miss out on any of these frequency range that is mentioned here, okay, which is about 950 to 1450 megahertz, where more than few subscribers are involved. The distribution system used is similar to the community antenna television system. The CATV system employs a single outdoor unit like MATV. So here also we have a single outdoor unit so that all the channels are made available simultaneously at the indoor receiver. But the only thing here is that it serves to a larger area. Okay, it serves to a larger number of users, and this can be actually used. Okay, it can be used by many users. okay, compared to less number of users, as we discussed in the previous technique. Okay. So the channels, instead of having a separate receiver for each user, all the carriers are demodulated in a common receive filter system. Okay. So the channels are then combined into a standard multiplexed signal. Okay. So we use multiplexers here, where we try to have multiple system, multiple inputs and single output. Okay, so we can even call it as a parallel to serial converter multiplexers. And in remote areas where cable distribution system may not be installed, the signal can rebroadcast from a low power VHF TV transmitter. Okay, so in areas where you cannot keep these antennas, okay, so in such situations we can use the antenna in an area where the reception is high and use cables to connect, and even the remotest place will get connectivity, because we are connecting just a cable from the outdoor uh, unit. Okay, so that is one advantage, but the disadvantage is the cable cost, okay, and the losses that can incur because of this cable wire. With CATV system, local programming material also may be distributed to subscribers, an option which is not permitted in MATV. Okay. So in community antenna TV system, it is just like the previously used cable connection, right? Wherein you will have your city news, okay, wherein you will have your local news, local channel. If any programs are to be announced or any announcements, okay, so these channels can be used for local purposes. Okay, um, say for example, if a news is specific, or if I want to broadcast a news to a particular community, okay, then a particular area, then these kind of systems will be much better than master, than MATV. CATV is going to be much better. So as I told you, okay, this is the station, okay, which employs a 8 meter. Okay. So as the frequency or as the number of users are high, okay, if you want a proper signal, then you have to make this antenna diameter also much larger. Okay, so once this is much larger, then it can be uh, it can receive a higher number of signals, and once these signals are taken, then it can be efficiently utilized. Okay, or even if there are more number of users, then there's not going to be much loss actually. Okay, because we have increased the bandwidth by having more diameter of the antenna. Okay, and this happens in C band, okay, which is a very good band. And the only downside that I feel here, is the size of the antenna. Okay, and the advantage is that local material can be transmitted for specific local groups. Okay, so the next one that we'll be looking into is transmit receive earth stations. Okay. So this is our transmit receive earth station, where it can both transmit as well as receive information. Okay, in some scenarios we will need both transmission and reception. Now, one best example can be your TT&C, okay, where I just cannot only receive signals, but then I'll have to even give commands to the satellite, where it can change its trajectory, it can change its movement. Okay, it can change the way that your antennas or your solar cells are positioned. Okay, so all these are needed, uh, and it is possible only if we have both transmit and receive type of stations. So the transmit receive stations provide both functions and are required for telecommunications traffic generally, including our network TV. Okay. The basic elements for redundant earth station are shown in this figure. Okay. So here you can see the basic elements where we use a switch, okay, and then we use a modulator. As I told you, we will have the same components, okay, just if in case one of the components here is spoiled, okay, if it goes down, then I can always connect to the other link, okay. So this is one such important concept where we have to employ as backup systems. Similarly here also, once the signal, the baseband, this is your panel of interconnection, the baseband signals, you have a switch which can actually select, okay, which can modulate. It depends on what kind of modulation you're going to employ. And then you have a converter, okay, the up converter, and right, and this also gets into your high performance amplifiers, right, and then your switch, then your antenna. Okay, so here you have bidirectional symbol, which means it is able to transmit as well as receive information. Okay, then it can even send back the information via switch, like how it receives from the switch. Okay, so it's connected to a baseband interconnection panel. So here you can even think of these standby kind of systems, okay, which is needed if in case one device goes down, then I can always connect back through the other link. Okay. Right. So the basic elements for redundant earth station are shown as seen in connection with transponders. Okay, these transponders were seen in your satellite systems, right, where it had multiple devices, okay, and it had the various frequencies that is divided and actually connected one by one. If you can recall the 36 megahertz and then 4 megahertz of guard band, okay, totaling up to 40 megahertz, right? So this concept was used in our transponders also. A duplicate or redundant unit is automatically switched into a circuit to replace a corresponding unit that has failed. Now this concept is very important, okay, because we have to look at failures. Okay, so if a system has failed, okay, then well, it's not just few rupees or few dollars wherein you can just replace it, because it's not here, right? We have to make sure that it sits there in the satellite as well as here in our base station, and there is a huge expense that happens. So in order to take this into consideration, we always have backup systems wherein if one fails, we can use the other system. So all these systems are shown in dashed lines, as I told you, right? All these are shown in dashed lines, okay, the dotted lines, which is nothing but the repetition of whatever units were there in the upper side, okay. The block diagram shown is more detailed in actually the next figure I'll be showing, where we do not have this redundant units, right? So here you can see this is actually the detailed diagram of your transmit receiver station, and this is just a glimpse of your transmit receiver station, okay, wherein you have your antenna feed, diplexer, power amplifiers, dividers, up converters, okay. So ultimately, see, you can see if there's a combiner here, there's a divider. If there's an up converter, there is down converter, modulator, demodulator. So whatever operation is happening here, the reverse should happen in the other side. Okay. Then here you will have multiplex, demultiplex equipment, DSPs, signals, baseband signals, and equipment to connect to terrestrial network. So terrestrial network is going to be our base station that is actually in the um, uh, located in few geographical locations, which is used for communicating with the satellite. Okay, so I hope you have understood this basic concept of transmit receive earth stations. Okay, and we will dive in deep, okay, in our upcoming class, and we will see as to how it is really important to have these kind of systems wherein we can transmit, we can send and receive signals, unlike the previous systems where we used to only receive signals based on the number of subscribers, the number of users. We can either employ community, or we can employ your master antenna type of systems. Okay, so we will get back with the concepts on transmit and receive antenna in our upcoming class. So students, do you have any doubts up to the concepts that we have discussed so far?
No, sir.
Okay, okay, fine. Thank you.